Q6848. What effect, if any, does ambient temperature have on propane tank pressure? A. It has no effect. B. As temperature decreases, propane tank pressure decreases. C. As temperature decreases, propane tank pressure increases. The correct answer is B. The ambient temperature does have an effect on propane tank pressure. Specifically, as the ambient temperature decreases, propane tank pressure decreases. Propane is stored in tanks as a liquid under pressure. However, it has a boiling point at atmospheric pressure, which means that it vaporizes and becomes a gas at a certain temperature. The pressure inside the propane tank is directly related to the temperature of the propane. According to the ideal gas law, as the temperature of a gas decreases, its pressure decreases as well, assuming the volume remains constant. This means that when the ambient temperature decreases, the temperature of the propane inside the tank also decreases, causing a decrease in pressure. In colder temperatures, the propane inside the tank has less thermal energy, and its molecules move slower. As a result, there is less pressure exerted by the propane gas on the walls of the tank. This is why propane tanks may have pressure relief valves to prevent excessive pressure buildup when the temperature drops significantly. It is important to consider the temperature effects on propane tank pressure, especially in colder climates or during winter months. As the temperature drops, the pressure inside the tank decreases, which can impact the performance and efficiency of propane-fueled appliances or systems. For example, if the pressure drops too low, the propane may not flow properly or may not generate the necessary vaporization for effective combustion. 6849. Propane is preferred over butane for fuel and hot air balloons because A. It develops higher pressure. B. It has a higher boiling point. C. Butane is very explosive under pressure. The correct answer is A. Propane is preferred over butane for fuel and hot air balloons because it develops higher pressure. Propane and butane are both commonly used as fuel gases, and they have similar properties. However, propane is preferred for fueling hot air balloons due to its ability to develop higher pressure. In a hot air balloon, the fuel gas is burned in the burner to heat the air inside the envelope and create buoyancy. The pressure generated by the fuel gas plays a crucial role in producing the necessary heat and maintaining the desired lift. Propane has a higher vapor pressure at a given temperature compared to butane. This means that propane can exert higher pressure in the fuel system, leading to a more efficient and controlled combustion process. The higher pressure allows for better fuel flow and atomization, resulting in a more powerful and consistent heat output. By developing higher pressure, propane provides greater fuel flow rates, which translates to a higher heat output from the burner. This is particularly important for hot air balloons, as they require a significant amount of heat to generate the necessary lift for flight. 7196. Prior to balloon flight on a cold, winter day, it may be necessary to preheat propane tanks because A. Ice may have formed in the lines to the burners. B. The temperature of liquid propane controls burner pressure during combustion. C. Propane needs to be at a temperature which will allow it to go from a liquid to a gaseous state. The correct answer is B. Prior to a balloon flight on a cold, winter day, it may be necessary to preheat propane tanks because the temperature of liquid propane controls burner pressure during combustion. Propane is commonly used as fuel in hot air balloons, and its temperature plays a critical role in regulating the burner pressure and ensuring efficient combustion. When the temperature of liquid propane is too cold, it may not vaporize properly, resulting in inadequate fuel flow and burner performance. During cold weather conditions, the temperature of the propane in the tanks can drop significantly, approaching or even falling below its boiling point. Propane exists as a liquid under pressure inside the tanks, and it needs to vaporize into a gaseous state before it can be effectively burned in the balloon's burner. The vaporization of liquid propane is essential for generating the heat required to fill the balloon envelope with hot air. If the liquid propane is too cold, its vaporization rate may be insufficient, leading to lower burner pressure and reduced heat output. This can result in inadequate lift and compromised flight performance. By preheating the propane tanks, the temperature of the liquid propane is increased, facilitating its vaporization and ensuring a consistent and adequate fuel supply to the burner. This preheating process allows the propane to reach the necessary temperature for efficient combustion and proper burner pressure control. 7196-1. The purpose of the heat exchange coil as used in hot air balloons is to A. Prevent ice from forming in the fuel lines. B. Warm the fuel tanks for more efficient fuel flow. C. Vaporize the fuel for more efficient burner operation. The correct answer is C. The purpose of the heat exchange coil used in hot air balloons is to vaporize the fuel for more efficient burner operation. In hot air balloons, the fuel, usually propane, is stored in liquid form under pressure inside the fuel tanks. Before it can be burned in the burner, the liquid fuel needs to be vaporized and converted into a gaseous state. This vaporization process is essential for efficient and controlled combustion, which generates the heat necessary to fill the balloon envelope with hot air. The heat exchange coil, also known as a preheating coil, is a component in the fuel system of a hot air balloon. It is typically positioned in close proximity to the burner. The purpose of the heat exchange coil is to transfer heat from the burner flame to the liquid fuel as it passes through the coil. This transfer of heat raises the temperature of the liquid fuel, causing it to vaporize and become a gas before reaching the burner. By vaporizing the fuel, the heat exchange coil ensures that the burner receives a steady supply of gaseous fuel, which is more readily combustible than liquid fuel. This results in more efficient burner operation, as the gaseous fuel can be burned more effectively and consistently, producing a stable heat output. 7248. The formation of ice in a carburetor's throat is indicated by A. Rough engine operation, followed by a decrease in oil pressure. B. A rapid increase in RPM, followed by rough engine operation. C. A drop in RPM, followed by rough engine operation. The correct answer is C. The formation of ice in a carburetor's throat is indicated by a drop in RPM, followed by rough engine operation. When operating in certain weather conditions, particularly in high humidity and low temperature environments, the moisture in the air can condense and freeze inside the carburetor's throat. This phenomenon is commonly known as carburetor icing. Carburetor icing can disrupt the proper air-fuel mixture required for engine combustion, leading to a decrease in engine performance and rough operation. The ice formation restricts the flow of air through the carburetor, causing a reduction in RPM, engine speed, and subsequent rough running of the engine.